Hi, my name is Randy Rowland. I'm responsible for product development for Terramark. And today we're going to talk about integrating public clouds. They asked me to have you fill out the survey at the end, so I got that checked off. So today what I thought we'd do in talking about this subject, I think to frame it, if we take a step back and look in the past on how we got here, it kind of gives us clues on what the future holds. We're also going to have a demo. Joel Steidley's going to show a demo of integrating the new vCloud Director with our Enterprise Cloud product. And then we'll talk a little bit about what's next. So let's start with the hosting era. So if we rewind to the past, companies, the way the hosting industry got started was as the internet become more of a prevalent technology, companies didn't have internal expertise or connectivity, and so they started to outsource their web-based applications to the hosting companies. But typically they continued to run everything internally. So this picture on the left is really intended to show an internal IT department using several different consoles to manage their infrastructure, systems management-wise. Change management, monitoring, and all the different functions. And typically they have several different consoles and they manage their environment. So as the hosting industry started to grow and the hosting companies went from tens of servers to hundreds to thousands, they also had to start deploying systems management software to manage the different infrastructure. But it was done a little bit differently. They had a different use case. Since most of it was IP-based or internet-based, they used different technologies to manage those. And the other big difference was the requirement for multi-tenancy. The internal IT department really managed their own business, maybe a couple business units, but the hosting infrastructure in a multi-tenant way. And most of the software available was not multi-tenant aware. So the hosting industry started building portals. And portals really what it was is a layer of software that still used some of the same systems management tools they use for internal IT, but break down information so that each client could get only the information that they needed for their assets that was running in the data center. And so the benefit there, the actual initial portals that were built were really kind of a one-way communication. It was like looking in a window, seeing what's happening at the data center, but not really able to interact with it. And I think it was fine because the way it worked is the internal IT department, they managed the back office, their hosting provider managed their web-based applications, and they really didn't need to communicate information between the two unless you're using it for back-end databases and whatnot. And so portals at the beginning of the hosting industry, it was let me log into a portal, let me see what tickets are going on, get information about monitoring of the environment, backup status, change management status, but it was a one-way interaction. I can go to get information about my hosted assets, but I can't really do anything. I could call the service provider, have them change it or send me ticket information, but there's really no programmatic access. And so there was really no integration. They had their portals, we had our internal consoles in IT, and I think that was fine for that part of the how we started. So then insert virtualization. The entire hosting industry was about bringing economies of scale. It started with the data center, right? Instead of having to build a data center for your web-based applications, I could buy a server or group of servers and only pay for the data center access for those servers. It also broke down economies of scale of networking. Instead of having to pull in big pipes to the internet, I can get a VLAN and pay per megabit from a bandwidth perspective. But that's the only two things that we really virtualized early on. Every client would still get dedicated servers, dedicated storage, dedicated network devices, security devices. And the only thing that we really virtualized was the data center cooling and the network assets. And when virtualization started to appear, it gave us an opportunity to go after the rest of the stack. So We started to virtualize not only the servers, which VMware is a big part of, where we can start to virtualize processor, memory, and storage, but we could also start to virtualize some of the specialized network devices. We got firewall contexts that were software-based, load balancer instances, so that you didn't have to deploy specialized dedicated devices per client. And the portal started to change. Specifically in Terramark's instance, we started to adjust our portals where when I log on, instead of just getting information about what's running, I can actually affect change. I can start to deploy new servers. I could change IP settings, firewall settings, and that's what began kind of this cloud movement, where I have a completely virtualized infrastructure and I have a portal where I can start to actually change and affect what's happening in the data center. And that changed everything. IT, instead of just looking at hosting for their web-based applications, the reason they didn't move more is because they lose control. As soon as it went to the hosting provider, I can't really affect it. I have to call every time I want a change done. But now the portal is allowing me to do infrastructure management, and I might start looking at putting more applications in the service provider than just the web-based applications. And that's kind of how we started this cloud movement, which is now IT has control of the operating system and applications that sit within the service provider. And so I'm more interested in actually deploying more. Furthermore, some of the things that we solved on the portal could give even more control than typically what IT has internally. So what I mean by that is, because we've written software to automate a lot of this change, one IT administrator can sit down and deploy a new server, change a network setting, add storage without having to go and visit every different department internally. So it's sped up the process so I can get computing resources to my business users faster. And that's kind of what started the cloud revolution. Insert APIs. So you start with portals, and then now that I can get programmatic access to these cloud resources, it opens up a lot of possibilities. I can actually start to transfer information and start controlling what is running in my cloud service provider from maybe the consoles that I'm running internally. And so this is a big step. APIs are a really important part of the cloud, and we'll talk about that a little bit more in depth as we go through the presentation. Most of the APIs today, though, they're really focused around infrastructure management, right? So it's the deployment of new servers, the adding processor and memory and storage, and network settings, all very infrastructure focused. And we'll talk a little bit about what I think is coming next. So the important parts of this discussion is, now that we've virtualized these assets, we've created portals and APIs, IT departments can have control of what's happening within their service provider walls. So the discussion's about integrating with public cloud. So based on how we got here, what are some of the things you should look for when looking at a cloud provider? What are some of the things that you should consider? So one of the first ones that I'll talk about is hybrid solutions. One of the things that's happened is, I think nearly everybody in IT today has some type of cloud initiative in their strategy, but not everything's ready to move to cloud. New apps, obviously, but there's a lot of systems that we still need access to that will really make the cloud proliferate. So hybrid solutions are important. I'm using hybrid not in a external to internal cloud metaphor, but more pulling in dedicated circuits to my cloud environment, being able to deploy physical devices for customers. We have a customer who has an AS400, and their line of business application has been written and runs on that AS400, but they want to use cloud for every other application they deploy. If you don't have the ability to have the ability to integrate that device or that system within your cloud environment, then there's only so much. It kind of limits your ability to deploy cloud-based applications. So not only do you need to integrate legacy systems and physical devices, you also need the ability to pull in circuits from the networks that already exist. So when you're looking at integrating with a public cloud provider, one thing you need to look for is how much can I move to the cloud and how much can I integrate with what I already have? That's an important thing to look at. Second is interoperability. So typically what I've seen in cloud adoption is that usually the first time a company uses the cloud, it's not usually through the IT department. It usually comes through some developer who signs up for Salesforce.com or a sales guy signing up for software as a service or platform as a service. And they've gone around IT for whatever reason. Maybe it's too slow. Maybe they just want to try something different. But at the end of the day, IT always gets involved, right? So as soon as an app becomes mission critical and there's an outage or a security risk or something, IT has to get back involved. And when that happens, they have to go and remediate the situation. A lot of times what happens in that case is IT starts to learn about these different cloud software services and platform services, and they actually start to certify or change the way that their development teams or business partners use the cloud. But what you really want to look for is interoperability. So most of the IT departments today have standardized on certain virtualization platforms, one being VMware. And so a lot of people are looking for a solution that's much like their internal department and internal deployment. So a couple things. VMware is an important part of it. The vCloud API, a standard API, I believe this is important because it is not a proprietary API. Multiple service providers will leverage this API as well as the new vCloud Director for your internal cloud. So when you're writing software or integrating your systems management platforms, be able to write to a standardized API gives you choice, which allows you to have a very functional relationship with your service provider. What you don't want to get caught in is in a situation where you've written something that's proprietary and now you're stuck because you're having bad service and you can't leave. If you have choice, then it allows you to hold your service provider's feet to the fire and make sure they're delivering on their SLAs. You know, a couple of other things about interoperability. Of course, broad OS and application support. We already talked a little bit about integrating private networks and physical devices. And so I think those are some things you need to look at when integrating with a public cloud. Another one is security. So security is a big topic around the cloud. I'd say there's two things to look at with your public cloud provider. One is architectural security. How is the platform built? Can you certify it? Is it built to IT best practice? One of the things that happens is this concept of cloud, if I deploy in the cloud, it's just taken care of, and that isn't the case. You need to understand exactly how it's designed. Can it get through your audit process? So you want to look at architectural security. You also want to look at what additional security services you can layer on with your cloud provider. Can you buy additional intrusion detection or log aggregation or any type of professional service to help you meet your internal compliance needs? One of the things that I've heard from a couple clients is a lot of times because the service provider has to build in a certain level of security to meet PCI compliance or FISMA with the federal government, a lot of times the cloud deployments are more secure than some of the internal data center deployments. So there's an opportunity for some, and I'm not saying in all cases, for you to increase your security profile by selecting the right cloud provider and buying the right additional services. And paying a service provider $1,000 a month to manage your IDS is probably quite a bit cheaper than buying your own software, deploying it, managing it, hiring the people to manage it. So a lot of times you can increase your security profile by selecting the correct public cloud provider. I'd say the last thing here is think about how it's going to integrate with your business. And probably the way this shows up the most is compliance. You need to make sure the contract you're signing with your service provider meets your contractual standards, that IT and the audit teams are a part of the process. You also want transparency. So one of the things that we talk about is if you deploy an application in the cloud, and I know it's not just out there, where is it? What data center is it in? what server does it run on, what type of equipment is it using. So you want transparency from your cloud provider. You want to get information about capacity management so that you can manage your efficiency. And another thing, you need to get granular billing data so you can bill back your different business units internally. So the other thing you have to think about when selecting and integrating with the public cloud provider is how you're going to integrate with the business. So that's the first part of the discussion. I'm going to turn over to Joel. So just a quick background on Joel's demo. What we're trying to show today is he's going to actually show an application that has been deployed within vCloud Director and also an enterprise cloud using the same APIs, and showing how it's an example of using the APIs to control two different cloud environments, internal and external.
So APIs have been around for a very long time. However, they've often been cryptic, difficult to understand, and very proprietary, depending on what application you need to develop against. In the recent years, we've seen a proliferation of web-based APIs, so they're much easier to develop against. We also now have multiple vendors using similar styles. We have the vCloud API that, again, multiple service providers use and multiple groups are developing against. Never before could you deploy something in a service provider, something outside of your control, and still maintain that manageability of it. People don't like to let go of what they have. They like to be able to control that. So today, we have these APIs available. We have people developing solutions around using them as well. There's VARs and other vendors that are creating things like Cloud Switch. We have a platform as a service that uses our APIs, such as Engine Yard, that have been able to use these to really run their business or be able to offer value-added services on top of these APIs. We also have communities now that are building applications, building SDKs, building libraries that we could use in order to develop these solutions in-house so that we could maintain control of our applications even though they may be far off from us. So as Randy gave an introduction, today we have a demonstration of using just two APIs, the Citrix NetScaler APIs and the vCloud API set, in order to create an application that gives us control of a multi-site application. That application resides on an on-premises vCloud Director, and then on the other side, Terramark's Enterprise Cloud. We're using a global server load balancer in the middle in order to direct traffic to both of those locations. So it's a fairly generic application. It's a standard web application. But to give you a little quick tour of Enterprise Cloud and Cloud Director, if you hadn't seen it, here we have a resource pool-based committed resource model in Enterprise Cloud. So we can see that this customer has purchased 10 gigahertz of processor, 20 gigabytes of memory, and we see that what the consumption is overall for their application. And we have, this is kind of the basic login information, so we see an overview of how that's performing at this location. We could take a look into a couple other things into the environment as well. We could trend over the processor over the last 24 hours, see what's going on there. And we also get a task list, what's happened in the cloud. So we have an audit trail, who did what, when, and what kind of changes did they make? So we could go back and see that. This is our web application here. We have our web servers. We have a Web 1, which is our gold VM, which is configured exactly what we need to for this web app, so we could clone across. And then we have our 6 web servers that are actually in a load balancer here, and each have equal access or are load balanced across here is configured within our environment. I did record this because we wanted to make sure that we get the right amount of time. All this code does work. We just wanted to make sure that we hit the right amount of time. So this is vCloud Director if you haven't seen it. This is when you log in. You can see your vApps that you've deployed. You can see also your VMs and they're running. You can connect to them, configure them, and manage them from here. So in the same instance, we have 4 web servers running on our on-premises vCloud, and then we have that golden image, Web 1, that we're able to clone that's configured so that we could scale horizontally in our application. So that's to fire up our simple .NET app. I'm not a developer, but I was able to do this in about a week with the right XML information to get me started, which is publicly available and documented. So this application actually could be configured to do multiple things. But so at the top we have the website application. So we click on the configuration, and we can see that we have the configuration of the name of the application. What's our global load balancer? Because I have a global load balancer sitting to direct traffic between the 2 sites. And I also have a monitoring URL. So this returns the health of my application. So I have this returning the health of the overall application and then per site as well. And we see on the left-hand side, we have our global load balancer slider. Right now it's set to 50% on both. So every other request goes to one location or the other. However, it's a sticky sort of request, so that request will continue to go to one location or the other. So this allows me to load balance or to consume resources in both locations all at the same time, rather than having all my resources stuck in one location. So I'm really utilizing that public cloud, using additional resources outside of my data center so that I could get to the flexibility of a cloud platform and be able to use resources outside rather than being stuck with my own. I also have configuration for each of these. So I need logins for my on-cloud deployment. And I also have that golden VM. What's the VM I want to clone to be able to scale horizontally? And that monitoring URL, again, looks for response time. And then if it gets a green, yellow, or red, whether that's performing up to my SLAs. We see here there's the URL for logging in. And the same thing with the Terramark Cloud. So I'm using just the vCloud API in both of these instances to be able to do this management. So we see here that my application is yellow, meaning it's not quite meeting my SLAs. So I need to do something in order to react to that. And so most likely I wouldn't have a little application running on my desktop and watch it, but rather I'm going to do this programmatically in my monitoring software. I see that although my site is okay, my local site is okay, my director instance is what's yellow. It's not performing up to my SLA standards. So what I want to do is I want to expand in my Terramark cloud, my enterprise cloud, and deploy a couple additional virtual machines. So I have 6 now. I'm going to click the plus, and then I'm going to go flip back to my interface. Now I see that automatically my VM is cloning. So that's cloning. Takes a few minutes. I did edit this down to just a couple minutes. And then we see that it comes online, is customized automatically, and then my application then adds that into the load balancer. So automatically, this machine is online taking traffic. So I didn't have to go in, click the buttons, but I was able to do this programmatically. So I would probably do this in my performance monitoring utility to do that. So now I have 7 virtual machines, and now I'm going to change the load balancer weight. I'm going to slide it down to more heavily weight the Terramark location. So 85% of the traffic is going to Terramark, and 15% is going to go to my on-premises deployment. And then we'll see that next time my monitor polls for performance time, it's now turned to green. So that was all automatic using APIs. This actually does work. It's not just slideware, but then we could make real decisions, real control of our applications outside of our environment, things that are running in the cloud. Now, of course, a lot of people are concerned about cost and controlling your cost and your resources as they run outside of your environment. Though we have fixed price models in Terramark's Enterprise Cloud, we could also programmatically shrink our environment. So I click the minus button. Again, we would probably do this automatically in our monitoring software. Then we look back at our load balancer. We see that machine has been removed from the load balancer, no longer taking traffic. It's been shut down, which is what it's doing now, and then it's deleted from our environment. So even though we're running our 2 different environments, I guess in this task list, I show all of the steps that are taken in there, and we see that that task is now complete. So that we have, although we've given up our infrastructure, we're now running it in the cloud, and we're running an on-premises cloud. We still have control. We have these APIs that even make it more monitorable, more manageable than many times our environments are today. Let's turn it back to Randy.
Yeah, in the last session we had a bunch of questions about the demo. If we want, we can. Is anybody having questions while Joel's up here about the demo and how it works? Okay, guess not. Yeah.
I don't have a vCloud record, nor do I have to play with it, but this global load balancing, is that our vCloud record, or is that your?
That's actually using the Citrix NetScaler global load balancing. So they have a very nice web API to use. It's very simple to write towards. Okay. So there's 2 APIs total in that demo. The vCloud, which monitors the on-premises or enterprise cloud.
So it's your actual code that's modifying global load balancing configuration.
Right.
It's actually almost the same question we got in the last one, and it's kind of ties into the rest of the presentation, so I'm glad you asked that one. Any other questions for Joel? You can come back. Yeah, there's one more.
So this is a demo application, something that looks pretty on the interface, but most likely you're going to take those same scripts, you're going to take that same functionality, and you're going to build that into your monitoring software. So if you have 3 or 4 clouds that you want to, or 3 or 4 locations from a provider that you want to load balance across, you would then have to probably, your demo would look a little bit different, right? You would just add multiple load balance options in there. It depends on your application too. Some people want sticky, some people want to do failover, and it all depends on how you really want that to work. But it probably wouldn't demo very well. Actually, I started off with 3 options. It didn't look very good for the demo, but it's definitely doable all with the API.
And the reason I asked Joel to put this demo together is the point is using APIs, you can start to develop apps like this or even integrate with your internal systems management software to start managing your public cloud instances, right? So it's very powerful. He had a week to put it together, took the APIs and was able to build a simple app. Over time, you can tie in more and more of those functions into your internal systems management platforms or leverage your cloud provider systems management platforms. Very powerful to do that.
And some people have come to the booth this week and said, well, can I use those APIs to create a solution in my environment that I take requests for VMs in? So they have a portal inside their organization where they need approval. They say, I want 6 VMs. Once that's approved, you could use our APIs or standard APIs and then deploy those for them automatically through your portal. And then they have those virtual machines at a cloud provider. So you can do a lot of workflow and things that you need to build to support your operations, even though it's not running in your operations directly.
Yeah. So let's go ahead and piggyback on this concept. So as we start to converge and our customers start to virtualize their internal data centers, leveraging the APIs like what Joel demoed today, you can start to have kind of information passing to and from your internal IT data center and your service provider or providers. But it's not completely done. Most of the APIs today are really infrastructure focused. And what we need to do, so this is kind of the future part of it, and it's to your question, which is there are other things that may not come out of the vCloud API that I need to have control of to really manage my IT environment. One may be a global load balancing function, but there's lots of other ones. There's a lot of systems management functions that you're going to need if you're going to actually truly use a multi-tenant or multi-public cloud environment. You want more information from your service provider than just, did I spin up a VM and how much RAM did I assign? You're going to want information about change management, ticketing, monitoring. There's a lot of information you're going to want from your service provider. So as we go forward, what we're focused on at Terramark is we already have the vCloud APIs to help manage the infrastructure. It's in its first, actually was launched here at VMworld in a 1.0 state. And that solves part of the problem. But there's a lot of other things that we've got to get information to our customers for their systems management approach. Some is change management data, scheduling information so that when you're internal looking at all the different change that you have going in your environment, you need to also know what's happening in your public cloud environments. You would like to see information about the tickets your service provider is working. You want to submit tickets and register tickets back in your own internal systems. You'd like to get capacity and performance data about how things are performing and how much capacity. Make sure you got a good, efficient use of the capacity from your public cloud. Another is usage data. This is for a couple of reasons. You want to know who's consuming what resources and what the billing impact is going to be. So in the future, when I deploy a VM, not only at the end of the month, I want to say, be able to tag each VM based on a project code or a business unit, get that information programmatically, how many hours did it run, what was my cost, so that I can make sure I bill back my client or my business appropriately. You're also going to want information about the applications themselves that sit within the VMs. So you want to monitor those, and you also want to get alerts for any outages or any type of failure events. Another thing that you're going to want to do is directory services. You want to be able to authenticate in your web apps in the same way that you're authenticating internally. And also data backup status. I mean, these are just a few items. These are not, most of these right here are not in the current vCloud APIs or most of the current cloud APIs, but it's where we need to go so that ultimately we can manage both our internal data center and our cloud providers. I wanted to take a little bit of a rabbit trail and talk about platform as a service. Just by show of hands, how many people here have an active platform as a service project going on internally? Okay, 1, 2. It's a big part. I mean, it's a big part of the keynote. It's where VMware's headed. It's where I believe the new apps are going to be developed on. But it's relevant to this because platform as a service, they have a lot of these systems management functions as part of their suite. They have purpose-built instrumentation. They know how to monitor and know how to provide systems management for their application development platform. And so you're going to have the same kind of integration with your platform as a service applications as you do with your infrastructure as a service provider. And we'll talk about Engine Yard here in just a second. The other thing that you're going to want to pay attention to is what level of service you're getting. So, I was reading an article the other day based on an industry analyst where she was talking to a customer who had just deployed a VM in the cloud, and I don't know how the conversation came up, but, well, who's managing the operating system? And the customer said, well, of course, my cloud provider. And she's like, no, I don't know about that. And so once an operating system has been deployed in an application, who is responsible for patching that operating system, doing all the systems management functions we have here? We have good information about deployment and the infrastructure APIs, but you still have to extend your systems management approach that you use in IT to those operating systems, or you need to make sure that your service provider is managing that on your behalf and get an SLA for that and understand exactly what functions they're providing for that stack. I just wanted I already talked a little bit about this, but Engine Yard is an example of a business who's built a platform on top of our infrastructure as a service offering. And they have started to instrument a lot of the systems management and security management directly into the platform. So when you deploy applications leveraging their platform as a service, a lot of the systems management functions they're taking care of on your behalf and can give you a view into that much more than just deploying a VM and managing it independently. So federation, we'll end with federation. What I think we're all after, if we can get more maturity on the infrastructure APIs and start to be able to surface some of the systems management functions so that we have truly a bi-directional pass of information, we can actually someday get to that single pane of glass where as a customer you have one console where you're managing your internal and external cloud providers all through and managing all the systems management functions and the infrastructure management. And this is still kind of a few years out, but a lot of the large enterprise software companies are working towards this, and this is what we want. The more control we can give the IT department, the more cloud adoption will happen, and that's our goal, is to continue to give more control. So I had one last slide just to talk about federation. When I first heard about federation, thinking about a piece of software that continues to move workloads from cloud to cloud because it's 1 cent cheaper here than it was there, or it's a different time of day. I think that's kind of a cool concept, and I think it's technically feasible, but I don't know how pragmatic it is. I do see that happening for certain types of apps, but for most apps, they may move one time, and whenever they move there, you don't really want to introduce change that could cause problems. Could cause an outage or could cause a loss of data. The other thing about mobility is I think you can move the networks, but depending on the size of the workload, it could take a long time or cost a lot of bandwidth to get a 400 gigabyte VM from one location to the other. So federation, to me, I think there's some practical uses for it. This continuous mobility is unlikely, in my opinion. I think maybe in 5 years it'll be a little bit more pragmatic, but today I think there's some specific use cases. I think you can create federation where you have a test dev environment and you move that one time into a production environment. We've also seen compliance where customers have to have separation in their applications to meet their compliance needs. I think another thing on federation that's important is performance. We're working on some ideas on creating some specialized computing zones where most apps can just use standardized processor and memory, but there are some times where you need more horsepower or a different type of storage array, a different type of I/O profile, where we can classify a specialized computing zone as maybe a different performing zone that's cost more per MIP, but it's got those characteristics you're looking for. So I think you can start to see where people will federate their standard cloud and their high-performing cloud or their specialized compute zones and help make sure they can maintain their cost. There's a couple of other ones that are obvious. DR and business continuity, that's an obvious one. Met with a client the other day who has, and I tried to write this, a long list of words, but they want to create policy zones where they have many different business units and different compliance requirements, and they'd like to take one zone and meet all their compliance for this business unit and a separate one that may not have as much and a lower cost, where they can control workloads in more of a policy zone it's designed for security, data retention, or protection policies that they can apply different workloads to. And I think that's another thing that we're going to see quite a bit of. It could be even in the same data center, but you may have, this environment's going to run intrusion detection, log aggregation. This one it isn't, and it's going to be at a little bit lower cost. So anyway, that's what I had for content today. If you guys have any questions or topics, we've got a few minutes, I think, here at the end. Costing? So the question was, how's costing working in public cloud? It's a good question. Are you talking about different prices for different? Yeah, I think it's one of these things where there are. What I find is that when everything's the same, if something costs 9 cents, 10 cents, or 11 cents, you optimize for price. But not all computing environments are the same. They have different data center quality. They have different infrastructure they run. They have different security. So I think what happens when you're an end user and you're looking at the difference between 9, 10, or 11 cents, that's an important thing for you. But when you're an IT department, price is in there, but it's not number one, right? They're more interested in extending and can I get access to my systems management platforms? What is the quality of the data center it sits in? What is the security architecture? And then you get to price. And if you can meet all those first items, if you don't meet those, they don't care what the price is. So I don't think all clouds are created equal. So I think pricing is a little bit different. The other thing is one of the things I'm a proponent of is not all gigahertz are created equal. You know, you have these new Nehalem Intel processors that are the fastest that we've seen. 1 gigahertz on that processor is a lot different than an older style AMD processor or Intel. So you also have to look at the actual physical equipment that's there, and there's going to be a price delta. I'd like to see the concept of a MIP show up eventually, where I can, instead of looking at gigahertz is the wrong label for measuring computing. It's got to be something else. And there is no industry standard, and I don't know that we can all get along enough to do that, actually. You know, I don't know that Intel and AMD are ever going to really, you know, find that MIP concept. And there's more than just processor MIPs. There's also IOs on the storage. There's also network quality and bandwidth. There's a lot of things I think we need to create so that when you're looking at service provider A, B, and C, how do I know that they're all created equal? I'm going to get the same experience, right? And I think we need to, over time, I think we will start to see measurements from independent bodies that say, hey, this is rated at this, and at least you have some information so you can make a better decision. So I gave you a long answer to your question, but. Yep. Yeah, it's a good question. So the question is the chargeback features. There's, you know, the public cloud has some really obvious answers. I think it's hard to do chargeback internally because if you're not careful, you just take the cost of the hardware and divide it by 36 months and apply a rate to it. But that's not all the costs, right? I think it's hard to measure your internal data center deployment costs and the people to run the data center and all the different people side of it. Plus, you know, you have all these studies that have been done by the different consulting businesses that says, hey, you know, the hardware is only 1/10 of the overall cost to manage it. And I think there is some truth to that. It's hard to measure that. I think when you buy from a service provider, you know what you're getting. You know what the price is because they're including a certain level of service. I think it can be a watermark. I've had a lot of people ask me, do you have some magic Excel spreadsheet that tells me exactly what it costs internally so I can compare it to yours? And I don't know that that exists because every internal operating environment is a little bit different. But what I will tell you is that most of the enterprises that we work with, price is important, but they're more focused on agility and core versus context, right? Can I get my sysadmins helping me? I think the future for the IT department, if you think about historically, it's been 50% IS and 50% IT operations, so software, and over time that changes and it becomes more IS, maybe 80% IS and 20% IT. But I don't know that the IT ops team actually lose their job because in the future there's going to be a lot more software to integrate. I think sysadmins that have historically been managing infrastructure will be repurposed to help integrate more software, right? So new software that's being built in the platform as a service vendors, software as a service companies. There's a lot of things you have to integrate to make sure that you're managing those appropriately. And so I know it's a long answer to your question, but I think the external service providers are a good watermark. And then the question is, how do you measure that versus your internal costs? And there are different ways of doing that. And I think there's a lot of information out there to give you guidance, but I think every business is a little bit different. I think it's actually secondary. The biggest reason people are moving to the cloud is agility and core versus context. And as long as the pricing isn't too much, the pricing is kind of secondary. Isn't the case for everything, but that's in general, I think, what happens. Another question? So I think the question. So your question is, how long is it? Yeah. So how long does it take to deploy that application he showed? Oh, developers for our software? Terramark, I don't know that we have, I don't know that off the top of my head. Terramark as a business is more of a service provider, right? We're not a software company. What I'd rather do is buy software. The software we write is more glue, kind of like that portal concept that I showed at the beginning. And so what I'm always excited about is like being here and seeing the new vCloud Director from VMware. That's exciting to me because I don't have to go build that now. I can figure out how to integrate that and tie some glue in to pull it all together. So the software development teams that we have, they're more focused on integration and glue and less about core tech development. So it's a fairly thin development team, right? But what we're most interested in is service provider, providing services and infrastructure, and secondarily write software and buy software to help us in that pursuit. So the time to we started development of our platform about 3 years ago. We're already in our second generation platform, and that's almost finished, and we're going to start our third generation platform in January. Any other questions? Yeah, so the question was, well, what's the status of uploading VMs into our platform? It's a good question. It's actually one of the things that's been on our roadmap for a long time. I expect that our enterprise cloud platform, we have a public cloud offering, vCloud Express, and our flagship, which is enterprise cloud. We'll have that functionality by the end of this year, and then I think within a month or two after that for vCloud. It is part of the vCloud API 1.0 spec. And the real reason that we haven't done it sooner is we were waiting for that specification to come out before we integrated ours because we didn't want to go build it and then have to re-architect it, re-engineer it. So we've just gotten that spec here at VMworld, so we're going to build that upload functionality as part of that. All right, well, Joel and I will be here for a couple minutes afterwards. I appreciate your time today. Thank you.